Algebra students, this is Ms. Paflin, and I'm going to go over lesson 18.1, solving systems of linear inequalities, representing solutions to a system of linear inequalities. In this lesson, you are going to want at least 2 different colored pencils or pens because we are going to be graphing systems of solutions when you're using 2 different colors. Looking at the learning targets, to master this concept, I can determine if an ordered pair is a solution to a system of inequalities. I can graph the solution set to a system of linear inequalities in 2 variables. Your vocabulary terms are system of linear inequalities, solution region, half plane, open and closed plane. So please make sure you're completing your Unit 3 vocabulary as you're working through these lessons. Task 1, graphing inequalities. So this is review back to lesson 16, and we did a foldable on this. So go ahead and pause the video, practice graphing. It says graph each linear inequality. It is important that you graph first and use Desmos to check your answers. So I would definitely graph first, go into Desmos. You can use inequality symbols using the keyboard, and then practice using Desmos to check your answer, because remember, you have access to that on the LEAP test, and you want to be able to know how to type in different forms of inequalities and equations to check your work. And then come back to the video, and I'll go over it as well. All right, welcome back. You should have done A and B. So y is less than 2/3 x plus 4. Think of this like an equation. Think of it when you're graphing as y equals 2/3 x plus 4 to just draw your line. Then you can figure out your shading and type of boundary line. So we always look at the constant. That number by itself is 4, so that's our y-intercept. 0, 4. We put our first point there. Then we look at the slope, which is the coefficient, the number next to x, m equals 2/3. So then from my y-intercept, I go up to right 3, up to right 3, up to right 3. I also need to show the line going across the entire graph. If you are just given an equation or inequality and there's no context, your line needs to go all the way across the graph. So if I go the opposite direction, I'm going down to left 3. Down to left 3. All right, now we need to go back to the inequality. So now I have my points for my line, but with an inequality, we either have a solid boundary line or a dashed boundary line. So if I go back up here, it's y is less than, it doesn't have the or equal to, so it's going to be a dotted or dashed line. It just has the less than. So I'm going to just do dashes in between, so not a solid line. And then my line is going to keep going forever, so I draw those arrows. So this is our boundary line. Then we need to shade in the solution region. So if it's y is less than, look at your y-axis. If you struggle to know which side to shade in, if I'm at 4, I need to, on the y-axis, I need to shade in all of the numbers less than 4. So I have 2, 0, -2, -4, so that means I'm going to shade below. So shade below boundary line. Now we've created a half plane, so I wanted to review some of this other vocabulary that I haven't talked about yet. This is called a half plane because we've cut the plane, or the graph is also called a plane, in half. So, and then open and closed plane, that refers to the type of boundary line. Since we have this dashed line and it's just less than, that means this is an open plane because this boundary line does not include our solution region. Now, if it was like y is less than or equal to, then it would be a solid line, and that would be a closed boundary line. So kind of think of it like in literal terms, it's open, like there's openings in these dashed lines. So this would be an open, if I could spell, open half plane. Okay, now moving on to y is greater than or equal to 3x minus 5. First, we want to graph that y-intercept minus 5, so it's at negative 5. Our slope is 3, so create it as a fraction. Go up 3, right 1. Opposite direction, down 3, left 1. All right, then we need to look at our inequality. It's greater than or equal to, so this is going to be a closed half plane, which means solid line. Then I look at the type of inequality is greater than or equal to. So again, look at your y-axis. If I'm at negative 5, I need to shade in all the values that are greater than negative 5. So I'm going to shade above the line. Above boundary line. All right, so that's review. That's what you already should know how to do. Now we're going to be putting these concepts together in this lesson. So down here, number 2, use algebra to complete the table with yes or no to determine which ordered pairs are solutions to the inequalities. Note, use the input-output process to determine if each ordered pair will give you a true or false statement. So these are the ordered pairs given, and we want to check if that's a solution to the inequality. So we have x and y values here. So let me do the first one to just review this, and then I'm going to have you pause the video and do it. So if x is 0 and y is 0, we just plug it in. 0 is less than 2/3 times 0 plus 4, and then you just solve it. 2/3 times 0 equals 0. 0 is less than 4. That is true, so we could put true or yes. It does say yes or no, so let's put yes, true. Then I plug the same solution into the other inequality, y is greater than or equal to 3x minus 5. So notice we're using these two inequalities that we already graphed. Now we're using algebra to see which ordered pairs are a solution to both or to neither, or individually. So then I plug in 0 is greater than or equal to 3 times 0 minus 5. 3 times 0 is 0. 0 is greater than or equal to negative 5. And that is a true statement, so I'm going to say yes. So it is a solution to both. So again, I will put a check mark, or you can write yes. Solution to neither, no, x. All right, go ahead and try the other 3 ordered pairs on your own, so pause the video now. All right, welcome back. You should have done these other 3 on your own. Remember, you've got to practice it independently to learn it yourself. So checking your work, so if x is negative 3 and y is 4, I would do 4 is less than 2/3 times negative 3 plus 4. 2/3 times negative 3, well, if I change that into fraction, 2 times negative 3 is negative 6. Divided by 3 is negative 2. So 4 is less than negative 2 plus 4. Negative 2 plus 4 is 2. So 4 is less than 2. That's not true, so I'm going to put no. Then I plug it in over here. 4 is greater than or equal to 3 times negative 3 minus 5. 3 times negative 3 is negative 9. Minus 5 is negative 14. 4 is greater than or equal to negative 14, so that's yes. So it's a solution to this y is greater than or equal to 3x minus 5, but it's not to this. So we would say no, it's not a solution to both, and no, it's not a solution to neither. All right, x is 6 and y is 10, so 10 is less than 2/3 times 6 plus 4. Again, make 6 into a fraction, multiply across. 2 times 6 is 12, 3 times 1 is 3, 12 divided by 3 is 4. 10 is less than 4 plus 4. 10 is not less than 8. No. All right, plug it in over here. 10 is greater than or equal to 3 times 6 minus 5. 3 times 6 is 18. 18 minus 5 is 13. 10 is not greater than or equal to 13. No. So that would be solution to both, no. Solution to neither, yes. All right, for 1, x is equal to 4, y is equal to 1. So y is less than 2/3 times 4 plus 4. 2 times 4 is 8. 8/3, so y is less than 8/3 plus 4. And then sometimes, you know, when I get to this, I know that y is not, or sorry, 1 is less than 8/3 plus 4. So, you know, if you get to a point where, like, you don't need to solve it further. You already know that 1 is less than 8/3 plus 4. So I'm just going to stop there and say yes. Sometimes you just don't, you know, don't take that extra time, especially when you're testing. And then 1 is greater than or equal to 3 times 4 minus 5. 3 times 4 is 12 minus 5. 1 is greater than or equal to 7. That's not true. Remember, we put that line through to say no, it is not equal to, or not greater than or equal to. All right, then solution to both, no. Solution to neither, no. So again, you can use the graph to check your solutions, but you can also use algebra to check your solutions. You have multiple options. How do the graphs above support your answers from item 2? Use evidence to examples from your table in item 2 to help explain your thinking. So I want you to pause the video and how do these solutions we just got in number 2, how can we also find those solutions on the graph? So I want you to pause the video and answer this on the lines, and then come back and let's talk about it. All right, so checking your work. So like 0, 0. We said yes here, so if I go back to the graph and I put a point at 0, 0, that's in the solution region. That's in that shaded solution region. So I can see yes algebraically and yes on the graph, that's a solution. And then if I go over to this graph, I also put a point at 0, 0. That's also in the solution region. So when we're talking about systems of equations, we are talking about two systems, two linear inequalities or equations at the same time. So this is a system of linear inequalities. And in order to find the solution to the system, it has to be a solution to both inequalities. So this one is yes to both. Then if we go to negative 3, 4, so I go left 3, up 4, negative 3, 4. That's not in the solution region. So that's not a solution, and we also said no here. So the graph proves that as well. Whereas over here, if I go negative 3, 4, that is a solution to one of my inequalities because it's in that shaded region. But it would not be a solution to both, which when we're talking about systems, it has to be a solution to both. 6, 10. So if I go on over here, 6 and up 10, that's a no. That's not in the shaded solution region. And we also got no algebraically. And then over here we got no, and let's check it on the graph. 6, 10. No, that's not a solution. And then the last one, 4, 1. So that would be right here. Yes, that is in the shaded region there. And then 4, 1 over here is no. So go make sure you have that written there. I explained it. So I'm just going to put student. Answers vary. You need to make sure you wrote down your answer and added to it with my explanation. Refer back to item 2. Which ordered pair is a solution to both inequalities? So let's go back to our table. Solution to both. The only one we got was 0, 0. Other than that, they were all either one or the other or neither. So we would put 0, 0 as a solution to both. All right, now I want you to practice. You already graphed these, but now you're graphing both inequalities on the same graph. So just like you did over here, but now we're putting them together. So pause the video and practice. Use the same colors. Remember color code. So I'm still going to use blue for this one and then pink for this one. All right, pause the video now and graph it. All right, coming back, so I'm going to graph y is less than 2/3 x plus 4 in the blue. And then with my pink, the other one was y is greater than or equal to 3x minus 5. So I'll just start with that one. So again, same graph. So we already did this. Start at 0, -5, go up 3, right 1. And then this one was the solid line. And then this one was shaded above. All right, then we have y is less than 2/3 x plus 4. So we started at 0, 4, go up 2, right 3, down 2, left 3, down 2. And then this one was the dashed line or dotted line. And since it was y is less than, we shaded this one below. All right, so this is why we want to use two different colors, because it helps to better see the shaded regions of, and compare and contrast. So I want you to pause now, explain how you can use the graph to, both inequalities on the same plane to find solutions to both inequalities. All right, so you should have answered, that should be number 6, got cut off on here. But pretty much the way we can use the graph is the solution to both inequalities would be in this double shaded region. See right in here between those two lines, those boundary lines, I have both colors shaded there. So that area in between here is going to be my solution region for both inequalities. And then this open half plane, it would, on the line, would not be a solution because it's the dashed line, whereas this closed half plane, that would be the part of the solution for both as well. So the solutions to both systems are all the ordered pairs in the overlapping shaded region and on the closed half plane, which is the solid boundary line, of the, we call that inclusive inequality, because it's including those ordered pairs on the line. So remember, it's inclusive for if it has like greater than or equal to or less than or equal to, and then this is non-inclusive because that's that open half plane. Those points on the line are not included. All right, this is an important definition to highlight. Solving a system of linear inequalities means finding all solutions that are common to all inequalities in the system. And then we have a mistake here. These are pretty much the exact same thing that you just did. So you get to cross those off, and we are not doing that. Oh, we are doing this one down here. Identify 2 more ordered pair solutions to the system. So let's do that one. So we already know that 0, 0 is a solution here. Grab another color. So we knew that 0, 0 is. So go ahead and pick 2 more, at least 2 more ordered pairs in the system. We just talked about what the solution to the system is. And down here, we're still doing this one. Identify 2 more ordered pairs to the system. This should be number 9. All right, pause it right now and do that. All right, so you could have a lot of different ordered pairs in this double shaded region, but so don't change it if it's not the same as mine, as long as it's somewhere in this area. So like, for example, I'm just going to pick this point. So that would be at -6, -7. Let's pick a point on this closed half plane, this solid boundary line. So like this ordered pair right here, that would be 1, -2. That's on that solid boundary line, which we call that closed half plane. All right, those are 2 that I chose. All right, number 10, graph the system of inequalities on the graph provided, then use Desmos to help check your answer, and then you're just practicing using, identify the 2 solutions to the system, and then it's asking you, is 4, -2 a solution? Show that your answer is correct using algebra, and then it'll give you another ordered pair, show that it's correct using algebra. So you have your resources. You can check your work on Desmos. I'm going to also post the key to this so that you can also check the key. But remember, your success is based on your effort. So you need to make sure you are completing these on your own, asking your group members if you need help, and then using Desmos to check your work as well as my key so you can check your answers to these questions on my key. So please advocate for yourself so that you can be successful, stay on task, and then you'll be prepared for the unit test. All right, thank you. Have a great rest of your day.